NASA's Perseverance rover, due to launch to Mars this summer, will search an ancient crater lake for signs of past life. But if biology ever existed on the red planet, what did it look like? Today, Mars is totally hostile to life. It's too cold for water to stay liquid on the surface, and its thin atmosphere lets through high levels of radiation, potentially sterilizing the upper part of the soil. But it wasn't always like this. Some 3.5 billion years ago, there was water flowing on the surface of Mars. It carved channels that we can still see today. And it had a thick carbon dioxide atmosphere, which would have blocked more of that harmful radiation from the sun. Water is the most common ingredient in biology, so it does seem plausible that ancient Mars once had life. Ever since we sent the first rovers to Mars, their main mission was to look for evidence of life. In the 1970s, the Viking missions carried out experiments to look for present-day microbes in the Martian soil, but the results were judged inconclusive. But by the early 2000s, high-res pictures of the surface of Mars and the newer rovers confirmed that Mars used to have water. The Curiosity rover, which touched down in 2012, explored a lake called Gale Crater, which might have supported life. And it did detect organic carbon-containing molecules that could have been building blocks for some life on Mars. But the Perseverance mission this year will go far further.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high and are the rim of Jezero Crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero Crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars' climate changed, Lake Jezero dried up and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero Crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
And what they hope to find is very strange. This is a stromatolite. Stromatolites are everywhere on Earth and are evidence of ancient life. They are fossilized pond scum, organic matter that has been compressed into layers and over millions of years turned to rock. But if you look carefully at their structure, you can see that they were originally organic. So one of the best places to study life on Mars is ancient life on Earth. A team of scientists traveled to Australia to look at these ancient fossilized pond scum rocks.
This, in a sense, is kind of a holy grail for us.
We're in the outback of Australia because this is some of the oldest convincing evidence for life on Earth, and the Mars 2020 mission and the ExoMars mission are going to be looking for signs of life in the ancient past on Mars, and it was a great opportunity to bring the mission teams here to really see for themselves what we're talking about when we're talking about ancient biosignatures.
This part of Western Australia, called the Pilbara specifically, it's really absolutely a mecca for understanding the record of life on Earth. This is one of the most important places on the planet, geologically speaking.
Members of the science team came out here to look at some of the oldest rocks that are on Earth. These rocks are anywhere from 2.5 to 3.5 billion years old, about the same age as the rocks that we're going to find on Mars. And what's very special about them is they have evidence of the earliest life on Earth.
The rocks you see right in front of me here, these wrinkly layered structures that we call stromatolites. Structures like this actually represent fossilized microbial mats.
A microbial mat is actually a structure preserved in the rock made by communities of millions and millions of microorganisms.
Basically fossilized pond scum in a sense. Microbes, bacteria living in a shallow water environment. And we believe that if life ever existed on Mars, it would have been purely microbial.
And those are left behind in the record that are very distinctive. And so we've been showing the NASA and European Space Agency scientists the details of what those textures look like.
When we say with Mars 2020, we're seeking the signs of ancient life on Mars, this is precisely the kinds of signs of life that we'll be seeking.
I've learned to be a kind of a Martian, to be in a harsh environment. My comfort zone is the laboratory, but here I can see that this is the real stuff. It's not just simulating stuff in the laboratory. This is a real good training for us.
It was really important to get the science team out here, and speaking for myself, I had seen pictures of rocks like this, and they didn't really convince me that they were the product of life. And when you see them up close and personal, it really tells the story that this was once life. And that's something you just can't get if you don't go out and look at rocks like this.
You can study it, you can read about it, but there's nothing like the practical experience of trekking around in the desert and really trying to think about, as we land our Mars rovers there and we look at the images provided by our sensors, how do we interpret that and follow the clues to try to find the kind of evidence that has been unearthed here in Australia.
Could Mars ever have supported life? And then to take the next step, did Mars ever host life?
We're just smart enough now about Mars to ask the really hard questions.
After digging in the lake bed, the rover will transit all over the area, including the shoreline, the river, the sand dunes, and the delta. NASA JPL say this is an exciting prospect. We believe the mission might not just throw up questions, but a few answers, and those answers could be planet-shaking. We are on the verge of a new phase in our understanding of Earth's nearest neighbor and life on Mars. The truth is out there. If you enjoyed that and found it fascinating learning what the new techniques are for finding life on Mars, please consider supporting independent science filmmaking on my channel via Patreon, where you can join a community of like-minded scientists who discuss the subjects of the films. These films always appear first on my Patreon channel with no adverts and an open discussion. So for $1 a month, come and join us. It's fun and it really helps support me make independent films for you.